Sustainable Aviation Fuel. The U.S. Energy Bioenergy Technology Office, BETO, empowers energy companies and aviation stakeholders by supporting the advancement of research, development, and demonstrations to overcome barriers to widespread deployment of low-carbon sustainable aviation fuel, SAF. Made from renewable biomass and waste resources, SAF has the potential to deliver the performance of petroleum-based jet fuel, but with a fraction of its carbon footprint, giving airlines a strong basis for decoupling greenhouse gas, GHG, emissions from aviation. The U.S. Department of Energy is working with the U.S. Department of Transportation, the U.S. Department of Agriculture, and other federal government agencies to develop a comprehensive strategy to scale up new technologies to produce SAF on a commercial scale. Learn more about this multi-agency strategy at the Sustainable Aviation Fuel Grand Challenge site. Sustainable aviation fuels, safe, reliable, low carbon. SAF is a biofuel used to power aircraft that has similar properties to conventional jet fuel but with a smaller carbon footprint. Depending on the feedstock and technology used to produce it, SAF can dramatically reduce life cycle GHG emissions compared to conventional jet fuel. Some emerging SAF lines even have a net negative GHG footprint. According to the U.S. Environmental Protection Agency, SAF's low carbon intensity makes it an important solution for reducing aviation GHGs, which account for 9% to 12% of U.S. transportation GHG emissions. A menu of sustainable ingredients for SAF production: an estimated 1 billion dry tons of biomass can be sustainably harvested each year in the United States, enough to produce 50 to 60 billion gallons of low-carbon biofuel. These resources include corn grain, oil seeds, algae, other fats, oils and greases, agricultural residues, forestry residues, sawmill waste, municipal solid waste streams, wet waste, manure, sewage sludge, dedicated energy crops. This vast resource contains enough material to meet the projected fuel demand of the U.S. aviation industry. Additional volumes of low-carbon fuels that fall for use in other modes of transportation, and the production of high-value bioproducts and renewable chemicals. SAF benefits beyond reducing GHG emissions growing. Obtaining and producing SAF from renewable and waste resources can create new economic opportunities in farming communities, improve the environment, and even enhance aircraft performance. Additional income for farmers. By growing biomass crops for SAF production, American farmers can earn more money during droughts by feeding this new market, and reap benefits for their farms such as reduced nutrient losses and improved soil quality. Environmental services. Biomass crops can control erosion and improve water quality and quantity. They can increase biodiversity and store carbon in soil, which can provide farm benefits and environmental benefits across the country. Production of SAF from wet waste such as manure and sewage sludge reduces the pollution pressure in watersheds while also removing the potent methane gas, a major contributor to climate change, from the atmosphere. Improved aircraft performance. Most SAFs contain less aromatic components, which enable cleaner combustion in aircraft engines. This means less local emissions of harmful compounds around the airport during takeoff and landing. Aromatic components are also precursors for antagonism, which can exacerbate the effects of climate change. Biofuel production supports American jobs. The United States is the world's largest producer of biofuels, contributing to our domestic economy, creating jobs and reducing GHG emissions. Expanding domestic SAF production will help sustain the benefits of our biofuel industry and generate new economic benefits, creating and securing employment opportunities across the country. These jobs include food production in farming communities, construction to build state-of-the-art biorefinery, production of SAF biorefinery and infrastructure for operation, aviation, including countless pilots, crew members, maintenance workers, and other industry professionals. BETO research brings more SAF to market. To meet U.S. and aviation climate goals, SAF will need more production lines and feedstock to meet increasing demand. SAF can be made with a variety of technologies that use physical, biological, and chemical reactions to break down biomass and waste resources and recombine them into energy-dense hydrocarbons. Like conventional jet fuel, SAF's hydrocarbon blend must be tuned to achieve the key properties required to support safe, reliable aircraft operation. In collaboration with biorefiners, aviation companies and farmers, Beto-funded researchers are developing new ways to produce SAF from renewable and waste materials that meet stringent fuel specifications for existing aircraft and infrastructure. Beto is working with laboratories and industry partners to develop new SAF lines and fuel formulations to enable the necessary testing and certification to ensure these fuels are fully compatible with existing aircraft and infrastructure. Emerging SAFs. SAF from wet waste, National Renewable Energy Laboratory drawing on the carbon energy stores of cheap, widely available food waste, animal manure and other wastes with high water content. SAF from wet waste is a carbon-negative fuel. Bio-based polycyclic alkane SAF. Los Alamos National Laboratory if enhanced with UV light and catalysts. Bioacetone made from a range of biomass resources such as corn, stover or bioenergy crops yields SAF with 12% more energy than conventional jet fuel. Are available. SAF from carbon-rich waste gases. Pacific Northwest National Laboratory waste carbon monoxide from industrial processes can be easily converted to alcohol to jet SAF by capturing and upgrading it to ethanol with bacteria.